chord. Okay, so today we're going to go over section 3.1. We're starting a new chapter. I'm going to tell you 3.1 is probably it's probably the most different of all the sections we're going to go over. Chapter 3 really leads into solving functions. So 3.1 is over solving quadratics. Actually, it's over quadratics in general, but it's kind of like a baby intro to solving, which is fine. It's not a bad place to, it's not a bad thing per se, but it's kind of its own section. You'll see that sections 3.2, 3.2, 3.3, and 3.4 all really go together well, where 3.1 is kind of its own thing. So any questions before we get started about anything? Any comments? I know I've gotten some good questions about the test. There was one question, I forgot who emailed me about it, and I need you to look at it yourself, but I believe it was question 4, and it's like the answer was either none of the above or none, and if it counted it wrong on number 4, please email me. I can quickly change that for you, but I can't find in Blackboard how to like just change it all at once. So if you look back at the test, go look at number 4, see if you missed it. If you put none and it said like the answer was none of the above or vice versa, just let me know. It's not a big deal. I will be more than happy to change that. It was just a goofy error on my side. Okay, so let's get started on 3.1. I'm going to put it on the document camera here. Rocking and rolling. Okay, so 3.1 is on quadratics. And the first thing your book goes over really is one of the two ways to write a quadratic function. And the first way your book goes over is, what is it called? The standard form. So 3.1 is over quadratic functions. And the first way your book goes over it is the standard form. The standard form looks like this. Now, it doesn't look like the typical ax squared plus bx plus c, which is what we're used to with quadratics. It actually looks like the shifting and reflecting kind of stuff. So it looks like this: a times x minus h squared plus k. And each part of this, the a, h, and the k, are going to tell us about the quadratic function, okay? They're going to tell us a little bit about the quadratic function. And I'm going to use an example here to kind of go through this, this setup. So let's look at one that's in this form. So g of x equals, let's say, -2 x minus 3 squared plus, let's say, 6. Why not? Well, no, let's say 8. 8. Okay. G of x equals -2 times x minus 3 squared plus 8. Now look, from what we learned in the last chapter, we know that this parent function is x squared, so it's a standard quadratic, right? The quadratic function. And then the -3 and the 8 are going to tell us where it shifts to. Now this -2, the minus we know means it flips, but the 2 we didn't talk about. That was with stretching and shrinking. I'm not worrying about this being perfect. I'm going to go through this transformation and then really how we're going to label it now for this section. So let's go over to the right 3. Yeah, Sherry, you click on your score when you go to group it. We're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Boom. Okay. So we shifted. Remember this standard quadratic, we shift it to the right 3 and then up 8. This minus sign means it goes down. Okay. I'm not going to fill this in yet, but it goes down. I'm going to talk a little bit about this because there's some things that are true for every single type of quadratic. First off, where this changes is called the vertex. So where either we go from up to down or down to up, that point is called the vertex. Now for this example, the vertex is going to be positive 3, 8. Okay. Now that is actually your HK. So your vertex is always your HK. And notice, it turns out that it's going to be minus HK. So if this was like a negative 3, it turns into a positive 3. And the K is always the Y value. So it's going to be opposite sign what's inside the parentheses. That's your X value. And then the Y value for the vertex is right here, is this plus 8. Okay, so that's our vertex for this one. Now also, every single type of quadratic has an axis of symmetry. An axis of symmetry. Now look, this axis of symmetry is a vertical line that goes through your vertex. It's a vertical line that goes through your vertex. So axis of symmetry. So vertical lines are always x equals a number. And it's always the x value of the vertex. So for this example, it's x equals 3. Okay. For this example, it's x equals 3. Okay. No big deal. So the a value, though, is negative 2. This tells us if our vertex is a min or a max, right? Remember, the fact that it's negative means that we flipped this this quadratic. Instead of it smiling, really it's frowning because this value is negative right there. So a equals negative 2, and I'm going to write because a is negative, the vertex is a max. Notice the vertex is a maximum up there. And it's because a is a negative. If this would have been positive, this vertex would have been flipped up this way, okay? And it would have made a vertex a minimum, actually. Okay. Questions about this? I'm going to do some more examples. I really didn't go over the formula here. I'll tell you, the formula is that the vertex is always negative HK, because you always take this number and you make it negative. And then what else? Oh yeah, the axis of symmetry. Is always x equals negative, like whatever this value is, that's going to be the axis of symmetry. Okay, that's going to be the axis of symmetry. Really, there should be a plus on there, the way this is written, because it's minus h. So yeah, it's going to be the opposite. I don't really like going over this with the equation. It makes more sense to do it with examples. And I kind of probably messed you up in a way by doing this equationally.
Mr. Shirley?
Yeah.
A while ago, down there where you have vertex is 3 and 8.
Yep.
You said something about the opposite. Now you just wrote up. Okay, you changed it. Okay, I didn't see that you changed it up there.
Yeah, I changed it. It was
okay.
Yeah, that's my bad.
All right, thank you.
No problem. Thanks for calling me out, though. That won't be the first mistake I make, I promise, or last. Okay, let's look at another one. Let's say we've got h of x, and I've got, let's say, 3x plus 1 squared minus 2, okay? And I'm just going to pull a few things out of this before I graph it. And I'm not going to graph, it's not going to be a perfect graph, but I'm going to graph it. But before I do that, I want to recognize what I have going on just from the equation. And just from the equation, I can pull out the vertex. When it's written in the standard form. Remember, if it's x plus 1, that means we shift to the left 1 unit. So the x value is going to be negative 1 here. And the minus 2 means we go down 2 units. So it's negative 1, negative 2. Okay. Now, the next part I'm going to ask is this: is this a max or a min? So is this a max or a min? Well, to figure out if it's a max or min, you've got to look at this A value. So I'm going to say, well, A equals 3. And because it's positive, I know that the vertex, therefore, vertex is going to be a minimum. Okay, the vertex is a minimum because A is positive. It's a positive 3. That just means that, when we look at this, it's going to have the smiling shape of a quadratic, not the frowning shape. Remember, the frowning shape came from reflecting around the x-axis, and we had to have a negative out here to reflect around the x-axis. That was back in that transformation section, 2.5. So we got the vertex, we got max and min, kind of ABC this thing. C, we've got, well, what's the axis of symmetry? Well, the axis of symmetry, remember, it's a vertical line that goes through the vertex. So it's x equals -1. That's the axis of symmetry. And D, I'm just going to do a rough sketch. This is going to turn into one of those problems that's like A, B, C, D, E, F, G here in a minute. But before we get there, let's do just a rough sketch of what we have going on. Okay. So we know we go to the left 1, down 2, right? And then we know our axis of symmetry is right here. So we're going to go to the left the same as we're going to the right. And what else? Oh, we know that that vertex is a minimum. So just for a rough sketch, I'm going to say it does something like this. It's not perfect. We'll get more coordinates on this here in a minute, okay? But for now, I just want you to kind of see the rough sketch. We've got the axis of symmetry going right there. That's x equals -1, right? So this is a good kind of what I'm talking about, what I'm trying to kind of get across here before we get started on figuring out all this other stuff about this quadratic function. And try to find how the book asks this, just to make sure I'm on the right page. I'm going to kind of hit all the ways the book asks it in one question, okay? So I'm going to steal one from the book. Let's say we've got, this is like number, it's like number 17, but I'm going to change it up a little bit. So let's say we've got f of x equals x minus 3 squared, let's say -4. X minus 3 squared minus 4. I'm going to ask a few different questions based off this. Okay, find the coordinates of the vertex. Yeah. So first, let's find the vertex. And I just want you to state if it's a max or a min and why. Okay, so vertex, max or min. B, okay, let's see. Use vertex, intercepts. Okay, intercepts. Okay, let's do axis of symmetry. Which one, that's not going to take that much space up. And then it asks for intercepts. So let's do the x-intercepts. And then let's do, I'm not sure how much space I'm going to need. Let's do a y-intercept. Can't have more than one y-intercept. We wouldn't have a function, right? And then, okay, so term without graphing with percent. Oh, domain and range, A, B, C, D, E. Let's find the domain. Range, we might graph it and then come back to that just to show what's going on there. And then G, let's just graph. We'll do it kind of a standard graph. I might need another piece of paper to do G. Okay, so let's start on this one. Okay. So the vertex, well, the vertex, remember, it's going to be opposite here because we go to the right 3 and then down 4. So the vertex is 3, -4. It's not flipped down because this A is not negative, right? The A, the A is just a +1. So therefore, if we know our graph's gonna be smiling, it puts the vertex as a minimum. And if you want to answer why, it's because A is positive. Okay. A, which is positive 1 here. A is positive. Okay. So A is done. So B, axis of symmetry, it's the easiest one. X equals 3. Okay. Now we need to find the X and Y intercepts. Okay, we got to remember how to do this. Remember, if you want to find the X intercepts, you just set Y equal to 0. Now for us, our Y value is f of X, right? Remember, that's just a fancy way to say Y. So I'm going to set 0 equal to X minus 3 squared minus 4. Now I've got to solve this thing. And I think we went over this on the first week of classes on the reviewing quadratics, but if not, I'm going to go through solving using the square root method. Okay, look, X minus 3 squared, it's by itself. I'm going to move the 4 over. So I get 4 equals X minus 3 squared. It's going to take a little bit of space. And at this point, I have to take the square root of both sides. But when I do that, I'm going to do it up here. When I do the square root of both sides, I have to attach a plus or minus to the constant. Okay. So I wind up with plus or minus 4 equals X minus 3. Now I've got to add the 3 to the other side. So I get 3 plus or minus 4 equals X. So I've got 2 different answers here, right? Keep going. I've got to say that it's 3 plus 4, so 7, and 3 minus 4, which is negative 1. So I have 2 different x-intercepts. When y equals 0, I get x equals 7, so 7, 0, and negative 1, 0. So that's my 2 y-intercepts, okay? My 2 y-intercepts, kind of neat. So this is the solving quadratics using the square root method, okay? If you want to look this up because it does not look familiar, solving quadratics using the square root method. Solving quadratics using the square root method. Okay, so the y-intercept. Now y-intercept's a little easier, I think, because you just have to put in x equals 0, right? The y-intercept occurs whenever x equals 0. So you get f of 0 equals 0. Remember, go up to this equation. 0 minus 3 squared minus 4. So we get negative 3 squared minus 4, 9 minus 4. Looks like we get a positive 5. Okay, so the y-intercept, that's when x equals 0, y equals a positive 5. Now what's nice about these, this gives us 3 more coordinates on the graph. So we've got the vertex, that's a coordinate. We've got the 2 intercepts, the x-intercepts, and the y-intercept. So this will give us a better idea of what this graph looks like. Okay, and I'm going to come back to domain and range. So I'm going to graph this. I can kind of do it over here. It won't be perfect, but I'm not looking for perfect. I'm looking for something that kind of represents what we have going on. Okay, so 3, negative 4, 7, negative 1, positive 5. Okay, so something like this should be fun. Two, 3, 4, 5, 6. Okay, so let's graph the vertex first. So 3, negative 4, right there, right? The y-intercept 7 and negative 1. So 3, 4, 5, 6, 7, and negative 1. And then the y-intercept is 5. That doesn't make any sense. I don't think I did that correctly. Huh. Something doesn't look right. What? Oh, you know what, guys? Oh, my Lord. Okay. I want to go back. We're all human, right? What's the square root of 4? 2. Oh, Lord. So I'm gonna fix this. I'm gonna use my red marker, and I'm gonna go through here and fix it. This is 2. Okay. So that would be 3 plus or minus 2. Okay. Now, so that's 3 plus 2, 5. 3 minus 2, which is a positive 1. So my x-intercepts aren't -1 and positive 7. They're actually positive 1, 1, 2, 3, 4, 5, and positive 5. They're right there. Okay. So disregard those other two. I apologize. It happens. Which makes more sense now with the y-intercept. So 1, 2, 3, 4, 5. So now my graph looks something like that. Okay. Now my axis of symmetry, if you want to dot it in here, is right there. And that's x equals 3. Okay. Now that's just an imaginary line. It's not that it matters per se, but we know that this graph, if it was drawn perfectly, it would be symmetric around that line. So now it's 3. This coordinate, though, remember, is 3, -4. I know it's hard to kind of see right there. So let's go back to domain and range. So the domain, remember the domain is how far to the left and how far to the right. With quadratics, your domain is always going to be all real numbers. That's a fancy way to say all real numbers. If you just love interval notation, which your book probably uses for solutions, so we probably need to stick to it. It's going to be -infinity to infinity. The range, though, really does depend on if it's going up or down, right? So the range here, the furthest down the range goes is the vertex because it's a minimum. So the furthest or the smallest y value we have is -4, right? It goes all the way down to -4, but then it goes up forever. So our range is -4 to infinity. Okay, -4 to infinity. Okay, I'm going to stop here. That's a lot of going on. A, B, C, D, E, F, G, right? A lot going on here. And I'm going to let you check it out and see if you have any questions. I apologize for making that goofy mistake there. But do you guys have any questions before? I'm going to give you one, and I'm going to ask you the same A, B, C, D, E, F, G, okay? But before I do that, I want you to ask me any questions you have. Get another piece of paper out here. Okay. So same questions, but now I'm going to give you a different function. Let's say g of x. G of x, we'll put a negative sign out here. So x, that way it'll flip it around, right? X plus 2 squared. And then let's say minus 5. Okay. And then I want you to answer the same question. So A was, what's the vertex? And is it a min or a max in y? Okay. B was, what's the axis of symmetry? C, I'm going to leave a little more room for this one, is the x-intercepts. And then D is the y-intercept. And then E, where do I go? Domain. You can write down the answer to domain right now because quadratics always have a domain of all real numbers. But then now the range will be different though, because they start and they stop and go back, right? They bounce. So that means they're not going to go forever up and down. Like this one, we know is going to be frowning, right? So it's going to go down forever and then stop and come back down. So ABC of G, let's graph it. And I'm telling you, I would graph it before I do E and F. So try this. I'm going to give you a little bit of time. Since I'm recording it now, I'm going to pause it. So if you're following along, you won't have to sit here for a few minutes.